Welcome to Talkin Science, where we dive into the stories making headlines in the world of science and space. I'm Matt Miller. Dr. Brad Tucker is here. Brad, happy Tuesday.
How's it going?
Really well, my friend. Let's get the headlines in this, the 38th week of 2021. SpaceX's first mission with 4 private people on board has returned to Earth. The US and Russia extend the mission for 2 of their current expedition to allow filming to take place on the space station. And a new calculation shows black holes are slowly shrinking from the pressure they emit on their surroundings.
This is Trekzone's Talkin Science. And you can get exclusive behind-the-scenes info and first-play access to all Trekzone podcasts by becoming a member today. Click join on every Trekzone video on YouTube. Go to the trek.zone/support or scan the QR code on screen throughout the show. Now, it's back to you, Matt.
Well, thank you very much, Ross. And a quick mention of our socials. Trekzone's on YouTube, Twitter, Facebook, Instagram, and your favourite podcast feed. Find us, like, follow, and subscribe. Leave comments and ratings, and that'll help us convince the algorithm we're worth it. Brad, too, on social media, at btucker22 on Twitter, and Dr. Brad Tucker on Facebook. Brad, things are still going okay for Queensland as I base myself in the tropical North Queensland town of Mackay, the Pioneer River behind me. Unfortunately, another week of lockdown for you and your fellow Canberrans. I'm sorry.
Yeah, we were also battling snow yesterday, so get stuffed with your tropical weather.
I'm terribly sorry. Well, look, in some pretty serious, to switch gears pretty quickly, some breaking news that is coming in and developing as we record the show here on Wednesday morning, the 22nd of September. Magnitude 6 earthquake has shook Melbourne, regional Victoria, southern New South Wales, Sydney, Canberra, Adelaide, and Launceston as well, and some aftershocks being reported by Geoscience Australia. Did you feel it down there? And I'm really kind of surprised. Earthquakes in Australia don't happen all that often.
No, I didn't feel it. I do know a few other people who did. There was one a number of years ago that was north of Canberra that I remember feeling growing up in California, used to that feeling. Earthquakes are not obviously common on this continent because we kind of sit in the middle of a plate. But you can get interplate pressure that builds up and releases earthquakes. There's been a few ones that has happened in the history of Australia. At a magnitude 6, that is quite big. If people remember some of the big California earthquakes that has happened, Loma Prieta in '89 and Longridge in '94 in LA, both those were around the 6 mark as well, so not dramatically far off. The epicenter was also a little bit shallow. It was only about 10 kilometers. So hopefully the damage is minimal. There are reports of damage already.
Yeah, absolutely. We're seeing some of those pictures on screen now with our breaking news super. So keep an eye on that one. Obviously, reports on that are going to be continuing throughout the day and week as the weeks, even as the cleanup commences. But for us, let us get into the show. And first up this week, as I scroll down my auto cue, 3 Chinese astronauts have returned to Earth after a 3-month stint on their space station. It's the longest space flight in the country's history, Brad, and they're not slowing down, as we've talked about in the past.
Yeah, in fact, this was all part of setting up Tiangong, which is the Chinese space station. As you said, they did a number of tasks and they returned to Earth. And a few days later, they set up a cargo mission with the next parts of the space station. People fail to realize, and we've talked about this before, last year, China had the most rocket launches of any country. They are rapidly doing this, and it takes multiple missions. They already knew that it would take over a dozen missions to get their space station set up. That's how the International Space Station was set up as well. So it doesn't happen overnight. So they have to be on the ball, and they have to move quickly in order to get it up to full operation.
Well, let's stay with China, and the lunar samples they brought back last year on Chang'e are being studied for fusion sources. What's this one about, Brad?
Yeah, when they landed on the moon last December and then returned back to the Earth, December 2019, the whole goal was to analyze the samples that they had, looking for both water content and helium-3. Helium-3 has always been hypothesized and slightly hinted at of being on the moon. No one really knows exactly how much there is or whether there's even a lot. But helium-3, the normal helium you think about, the one that you breathe in from party balloons and makes your voice change, is helium-4, 2 protons and 2 neutrons. Helium-3 has one less neutron. What that means is it's a great fusion source. It wants to bind to an extra neutron. You smash the neutron into it, you get fusion, hydrogen bomb, but in this case, helium. So a lot of people, maybe if there's a lot of helium-3, it's good as a fuel source for fusion reactions. Therefore, fusion fuel, energy, rockets is one of those big other ideas in addition to the water resources. So the fact that they're analyzing these rocks they've brought back to look for it is no big surprise, but confirmation from them, the scientists there, that indeed they are looking at it rather than just kind of being thrown around as an idea.
Well, it was an all civilian affair for SpaceX last week, Brad, with 4 private citizens flying in a world first spaceflight on Inspiration 4.
Yeah, look, it was quite remarkable to see the whole thing unfold, and it worked mostly flawlessly. Essentially, there was, a few growing pains, we'll say, but the first time for non-astronauts, they weren't just that they weren't ex-military, but they were not astronauts. They were not part of a space program. They were quote unquote white regular people. I wouldn't necessarily say a billionaire is a regular person, but the other 3 were mostly regular. And they were in space for this 3-day mission, very different in a lot of ways to the Virgin Galactic and Blue Origin flights that we saw in July, but nonetheless, no less exciting. In fact, exhilarating, I think, for all 3 on board during that time.
Absolutely. Well, Jared Isaacman just up and paid for everyone's seats. I guess it's nice to have rich friends. He did run a competition to see who would be joining him. And as you say, ordinary people just going about their everyday lives and having something to contribute. They obviously had to perform an actual function on the ship as well. So they got training in that. But all civilian, very incredible, makes it reachable. And it was all for a worthy cause as well, with St. Jude Children's Research Hospital benefiting for the hundreds of millions of dollars Jared paid for those seats.
Yeah, so the goal was, I think, to raise $200 million, with Jared contributing $100 million, and through various initiatives trying to get the other $100 million. Part of that, as you said, was this raffle prize that was gone to go to one of the seats, the one that Chris took. And I love the story because Chris never won that raffle. All the money went in, and you had to donate at least $10, so 13 Australian dollars. And Chris's friend won, but didn't want to go, so that's why Chris went. I think Chris owes moving and airport pickups the rest of his life to his friend,
Yeah.
but
Yeah.
fair enough. It's a very personal story that you can relate to, instead of being a billionaire who could donate $100 million. I think there's very few people who can relate to that angle. But to something like that, it's quite remarkable. And so with that drive, plus they'll be selling some things from their flight to as an auction to raise money for the St. Jude Children's Hospital. They're hoping to reach that goal of $200 million.
Now, I believe that the docking module was used normally by Dragon to connect with the space station, made way for a Portaloo, but being in the cupola, the 4-person team was afforded spectacular views while answering the call of nature, this dome of glass, and just being able to look out with almost 360-degree views.
That's right. It's the ultimate, and is anyone looking at me going to the toilet ultimately? Well, technically the whole Earth was. They just didn't know it. But as you said, they had to modify the way that capsule was used for long-term use. As you said, normally it's just a ferry, so they don't have to deal with these issues. They're just going up to the space station, and the maximum flight to the space station is 24 hours, not 3 days. Usually it's much quicker than that. So they had to obviously do some modifications a bit to make it for a sole flight use, one that clearly they want to use on other future flights. However, these modifications meant that there was some description that the facilities, let's say, were not working as well as they wanted them to. The ventilation, let's say, and the suction that helps you pull away your waste wasn't as suctioning-y as they wanted.
Uh-oh.
So clearly some work still to be done in the design. But it just goes to show these are these little things that build in that astronauts go through lots of training. They go through training about how to use and diagnose the problems, even speech and eating problems, all these little things that are part of the regular training for professional astronauts didn't necessarily make this training. Now, they did have some training, but there's just so much to it that, it's a learning curve. And I think as much of anything, it was useful to see what do you need to do to prepare people for these journeys into space, not just for 8 minutes like in the Virgin Galactic and Bezos flights, but 3 days and at very high altitudes.
Exactly right. Well, in all, as you say, they spent 3 days in orbit, higher than the space station, further than Virgin Galactic and Blue Origin. SpaceX don't need the space tourism market, but they sure know how to throw one hell of a good party, don't they?
That's right. This has never been part of their huge business model. They've always viewed themselves as transportation. And that may be taking private astronauts, as we've talked about with Axiom Space, to the space station, but clearly shows that there is an interesting market that they can fulfill and use. And I don't think one they're going to shy away from anytime soon. And that there's maybe interesting options for them as they build more capsules and they build more options. And this is kind of how this whole new market it's finding its feet. We talked about some of the FAA problems and Virgin Galactic veering off course. These are just growing pains. These aren't necessarily anything bad or good or unsurprising. When you have this whole new field of options and ideas, you have to see what not only people want, but can be done as well.
Exactly right. Well, Mark Vande Hei and Pyotr Duprov will be hanging around the space station until next March as Roscosmos and NASA juggle the crew roster to get a Russian film crew up. As we talked about a little while ago, they're beating Tom Cruise to filming on the space station for the first time, Brad.
And this is all directly related to Inspiration 4, right? They're beating Tom Cruise because Tom Cruise's mission is now next year. So Inspiration 4 was able to take place in the past week. But the consequence of this is there's essentially too many bums and too few seats. It's a classic problem people can relate to. The normal way this works, especially with Soyuz or even SpaceX Dragon or those sorts of things, the new crew goes up, they kind of do a handover, and the other crew comes down. Now, they always need a capsule up on the space station, so there's a seat for every person, so that if there's an emergency, you can evacuate. So that is not something that they will ever change. So the consequences of this is that given the rotations are happening every 3 to 6 months, and the actress and director are only supposed to be up in the space station for 2 weeks, so obviously they're not going to be able to be up there for a long time. They need 2 of those seats coming down, meaning there's 2 less seats for 2 less bums, meaning 2 astronauts are spending a little bit of an extra stay in space, all to make way for this movie.
It is an incredible logistical problem, probably a good one to have. Let me see if I've got this right. The lay of the land is that Vande Hei, who spoke with me before he flew, and Duprov will extend their mission for 6 months. Director Klim Shipenko and actress Yulia Pereslid will join cosmonaut Anton Shaklarov. Russian accents are not my forte. Those 3 will be on a Soyuz capsule up to the station. As you say, they'll spend 2 weeks filming scenes before returning with 3rd expedition member Oleg Nivitsky, who is there at the moment with Vande Hei. I think that's everyone, Brad, the juggling around. And Vande Hei basically said, oh, well, I get to spend another 6 months on the space station. That's fine by me.
It is, and that was part of the warning. He kind of knew that this issue may come into it, and we even kind of talked about this may end up being an issue. These are just these interesting logistics that you have to deal with. Obviously, having enough people, crew rotations. One of the benefits of having more capsules like SpaceX Crew Dragon and eventually in the future the Boeing Starliner is there's multiple of these rotations, so you can rotate out a little bit quicker if you need it, instead of, again, waiting for the next ride, which may be 3 to 6 months. Now, there will be a SpaceX Crew Dragon mission in the meantime, but there's other people who have to be rotated off. So it's a very busy logistical nightmare in order, as you said, to coordinate all this. especially when one is an actress who is not quite used to the customization of space and the lack of luxury, let's say, that will before her in the coming weeks.
Exactly right. It is highlighting the current lack of a solution to Soyuz seat availability for NASA. Brad, you mentioned SpaceX, that's happening, but Soyuz is still being relied upon as well. Van der Height traveled on a seat on-sold to the US from Axiom Space in exchange for a future commercial crew mission seat. Negotiations are still ongoing between NASA and Roscosmos, Brad. What's the sticking point?
Yeah, so I mean, and this is the interesting point because one of the issues is that Roscosmos has not recognized SpaceX as a certified way of taking their cosmonauts into space. Now that means they will never be able to put their people on that seat, which kind of means that this quid pro quo, which has always been the basis of the U.S.-Russian alliance, let's say, in trade, doesn't exist. Now, in the past, it's always just been paid. NASA paid directly for these seats for Roscosmos because this agreement was reached because there was no other way. Now that the U.S. has another way, but the Russians don't recognize it yet, and I don't think this is them just necessarily saying, you know, finger up to Elon Musk or something like that. You know, they have not done all of their full checks for a private company to take their cosmonauts, and that is very valid. You know, the U.S. did a lot of this, so it's not saying, hey, they're just discounting it. But you know, as we talked about repeatedly, this threshold for human spaceflight is so high, and the fact that it's a relatively new player, you know, there's a lot more scrutiny that needs to come down. So once that certification happens, then it's going to be very easy to say, all right, well, we'll put a Russian on the next SpaceX, and then you can put an American on the next Soyuz. Until that happens, you're going to have that limit. And it doesn't bode well at the same time that Boeing has had as many problems as they've had because they were obviously hoping to do a certification of both kind of at the same time and use this as a, hey, we have two capsules that can take people into space. Therefore, we have lots of options for these trades. That clearly isn't happening anytime soon. So that has messed with the timeline a little bit as well.
Now, this extension will put Van der Heij at 353 days in orbit, breaking Scott Kelly's record of 340 before he'll be returning. Something he says he was prepared for, as you mentioned as well. And he's happy to continue the life experience of living on the space station and floating high above the Earth. I do wonder, though, even the wonder of space can't compete with your own bed, Brad, I'm sure.
Look, I mean, I think he'll be glad to be home at that time. Let's say that, but he'll definitely make the most of the opportunity. But these are the sorts of things that are going to have to be budgeted, not just when actors and actresses go up to film a movie in space, but private citizens are on trips, or Axiom Space is sending private astronauts. All of this needs to be folded into the calculations and supplies, resources, those sorts of things. So we talked about before, there's a finite amount of sleeping quarters. In fact, fun fact, with the SpaceX Crew Dragon flight, there were 7 toilets in space for the first time because they had the SpaceX, they had the Soyuz, they had the space station, and they had Tiangong. So, you know, as the more infrastructure is built, you can support more people. But in the process of doing so, you're going to have these growing pains.
Well, lastly this week, Brad, physicists at the University of Sussex have discovered that black holes exert a pressure on their environment.
Yeah, so this is kind of a really cool idea, and this goes back to essentially what happens with the singularity of what we call the black hole and how it interacts with its neighboring space. Since the 70s, with Stephen Hawking, we always had this idea of this Hawking radiation that gradually black holes could leak information and therefore radiation and energy back out into space, and that over time being oodles and hundreds and hundreds and hundreds of billions and billions and billions of years, that over time that information or energy could cause the black hole to evaporate. Well, the secondary calculation, unrelated but in parallel, shows that indeed there appears to be what, for lack of a better way, is actually a pressure being emitted on this black hole. But instead of the pressure being pushed outward, it's a pressure being pushed inward, i.e., energy is being exerted on the black hole. Not too much dissimilar to this idea that these black holes are leaking energy into space.
Well, quantum gravity is this thing that leads to that pressure. The extra figure that stumped scientists at the University of Sussex was presenting in equations they were running, and it was a meaningful discussion on Christmas Day last year that the realization occurred. I've said it before, Brad, science never sleeps, not even for a major religious holiday.
No, not especially when you're trying to connect quantum mechanics and general relativity as they're trying to do, because this is the crux of the problem. We have these laws, Einstein's laws of relativity, that describe the large scales of the universe, and therefore what happens with black holes. You then have quantum mechanics, the smallest scale, that governs how things work. You have these. There's no connection at this point between connecting quantum mechanics and relativity, and trying to get that as a big goal. And one of the things what they're saying is quantum gravity is using an interpretation of quantum mechanics to describe and calculate gravity, give a very interesting result. And when you find something like that, it definitely is shocking, no matter what day of the year it is.
Well, can you help me understand how scientists can go from a curious result in an equation to understanding quantum mechanics, applying it to general relativity? What does it all actually mean, and what's the exhilaration that feeling must cause?
So, I mean, ultimately, what they're trying to do is they were looking at something called entropy, and that is the way chaos and organization happens, i.e., you going from a less organized to more organized world. It's a fundamental of thermodynamics. When you build this in terms of energy and energy loss, you start to realize that things like pressure can be described by the way energy is moved in a organized to disorganized way, i.e., entropy. Um, when you sweat, when you release heat from your body, it happens in a processed way. You're emitting energy, but it doesn't just happen chaotically. Now, there's a very fundamental to this, and that is that when you try and reconcile what we see in a black hole with this energy loss that Hawking has had, and then what they were calculating, they realize, well, yeah, this is kind of this energy, but it's the energy going that way, i.e., there is something from space applying to the black hole, as you would expect. And this seems to be the exact as what you would say is a bleeding out from the black hole. Now, if this is kind of losing you, this is why it lost them a bit, because they're really trying to reconcile these two scales of the universe that is a big aim of physics that is just it's kind of, you're making a jigsaw puzzle, and it's 1,000 piece puzzle, and you're missing four pieces, and the picture isn't complete, and the four pieces are somewhere, you just don't know where they go, because you don't even know if they're actually the right pieces. That's what they're trying to solve right now. We don't even know if these are the right pieces. We don't even know where they go, but we know something is clearly missing in uniting the smallest scale to the largest scale. And when you get a clue as to what maybe one of these puzzle pieces are, you get excited.
Well, for the first time in 3 seasons of Talkin Science, Brad, you stumped me on this story. I have been able to sort of muddle my way through in the past with this one. It's good that it's confounding the scientists as well, because it certainly confounded me. But certainly very interesting. We're learning a lot about black holes in the last couple of years, from seeing the first image of an actual black hole
Yeah,
now through to understanding that they're going to eventually die. They're the dying
exactly.
remnants of a star, and now they themselves are going to die as well.
And this has just been one of these things lurking since the 70s when Hawking came up with that. Could black holes really die? And here is another piece of evidence that indeed maybe they can and actually are showing signs of it. It's funny because it goes to this fundamental thing. We still don't have the perfect view of what gravity is. And this is what they're trying to reconcile. We know general relativity, we know how we can describe gravity. Particle physicists will say, well, gravity can actually be an individual particle, something that we can measure and see in a lab. Others are unsure. And trying to get those clues to reconcile this whole picture is something that is being grappled with across many of fields. And black holes represent this uniting of these two scales. I think this is what makes it special, is that these two giant scales that generally don't relate too much relate to each other directly. at a black hole. And so, as you said, we're learning a lot more black holes, and they're clues to understanding the very nature of what the universe is.
Very exciting indeed. Well, just before we go, a look ahead to this week's Talkin Science interview. Your colleague, Dr. Matt Roth, there at Mount Stromlo, will be beaming in to explain the origins of gamma rays, one of the most energetic forms of light in the universe. He's busted that mystery. Where do you start with a puzzle like this?
Okay, so the basis for this whole project was essentially that we've sort of gained a better understanding of how cosmic rays, so these are just regular particles that move at relativistic velocity, so they have a velocity very close to the speed of light. And we've sort of gained a better understanding of how they move through the interstellar medium, which is the gas that sort of fills the galaxy between the stars. And it was sort of quite critical to understand, how many of them are actually converted to, how much of the energy is converted to gamma rays, and how many cosmic rays escape from a galaxy once they've been produced. So that was the fundamental bit.
And members have first play access to that interview right now. Sign up with the join button below this video on YouTube, or go to the Trek.zone/support to get access for less than a cup of coffee a month. Brad, it's great to pick apart the stories of the week with you. We'll do it again next week.
Sounds good.